This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to today's discussion. We're diving into the fascinating world of interactive physics simulations, specifically the Reflection from Wall Simulator. It's a web-based applet designed to help students visualize wave reflection.
Indeed. And the beauty of it lies in its simplicity and accessibility. It uses readily available technologies like HTML5 and JavaScript, making it easily embeddable in any online learning environment.
Exactly. It's not just about the technology, though. The design itself is quite intuitive. What are some of the key features that make it so effective?
The interactive elements are crucial. Students can toggle the visibility of a virtual mirror, adjust various wave parameters using sliders, and control the simulation's playback. This hands-on approach fosters a deeper understanding.
And the visual aspect is key, isn't it? Seeing the wave reflect in real time is far more impactful than just reading about it in a textbook. Let's talk about the core purpose of this simulator. It's designed as an interactive learning tool, right?
Absolutely. The goal is to provide a dynamic and engaging way for students to grasp the concept of wave reflection. Instead of passively receiving information, they actively participate in the learning process.
And that active participation is what makes all the difference, isn't it? It's not just memorizing facts, it's about building an intuitive understanding. The use of HTML5 and JavaScript is a smart move. It makes the simulator incredibly accessible.
Precisely. No need for specialized software or plugins. Any browser will do. And the provided iframe code makes embedding it into websites or learning management systems a breeze. The seamless integration is a huge advantage.
That's a significant point. It's about making educational resources readily available and easily integrated into existing workflows. The user interface seems quite straightforward. We have the toggle for the mirror, sliders for adjusting parameters, play/pause/reset buttons, and even a full screen option.
Yes, the design prioritizes simplicity and ease of use. The controls are intuitive, allowing students to focus on the physics rather than wrestling with the interface. The sliders, for example, allow for experimentation with different wave properties.
And what kind of parameters might those sliders control? Wave frequency, amplitude, perhaps even the properties of the reflecting surface?
Exactly. Those are all possibilities. The specific parameters would depend on the implementation, but the ability to manipulate these variables allows for a deeper exploration of the underlying physics.
The document mentions sample learning goals, although the specifics aren't provided. What kind of learning objectives would you expect to see associated with this simulator?
The primary goal would be to develop a conceptual understanding of wave reflection. Students should be able to observe how waves behave when encountering a boundary, understand the relationship between incident and reflected waves, and perhaps even explore the effects of different boundary conditions.
And the For Teachers section suggests supplementary materials or pedagogical guidance might be available. That's crucial for effective integration into the curriculum. The credits clearly identify the developers Fu-Kun Wang, Fremont Teng, and Lu Kang Wei. This transparency is important, isn't it?
Absolutely. Attribution is essential, especially in the context of open educational resources. It acknowledges the effort and expertise that went into creating this valuable tool.
This simulator is part of a much larger collection of resources on the Open Educational Resources/Open Source Physics at Singapore platform. This breadth of resources is impressive.
It is. The platform offers a wide range of interactive simulations covering various physics and mathematics topics. This comprehensive approach ensures that educators have access to a diverse set of tools to support their teaching.
And the fact that it's all open educational resources makes it even more valuable. The Creative Commons license is a key aspect of this resource. It promotes accessibility and collaboration.
Exactly. The OER nature of the platform allows for free use, adaptation, and sharing, fostering a collaborative environment where educators can build upon existing resources and create customized learning experiences. This is a powerful model for educational innovation.
It's a win-win for everyone involved. Let's discuss the potential applications of this simulator. Classroom demonstrations are an obvious use case.
Yes, teachers can use it to visually demonstrate wave reflection principles. It's far more engaging than a static diagram. Students can also use it for independent exploration, experimenting with different parameters, and observing the results.
And the embeddable nature makes it ideal for online assignments or learning management systems. The simulator interactive nature, web-based accessibility, and integration within a broader collection of resources make it a powerful tool.
It truly is. The combination of visual learning, active participation, and easy accessibility makes it a valuable asset for both educators and students. The potential for adaptation and customization further enhances its versatility.
And the open licensing encourages widespread use and adaptation, fostering a collaborative environment for educational innovation. This is a great example of how technology can enhance learning. The study guide includes a quiz. The first question asks about the primary visual element that can be toggled.
That's the orange mirror. Students can switch its visibility on or off to observe its effect on wave reflection.
The next question focuses on the adjustable elements besides the play/cause/reset buttons.
Those are the sliders, which allow for horizontal adjustment of various wave parameters.
The quiz also asks about the simulators category within the website's structure.
It's found under General Waves, within Energy and Fields, and further under Energy, Work, Power, and Foundations of Physics. The breadcrumbs clearly show this hierarchical organization.
What about the function of double-clicking on the screen?
That toggles the full screen mode, enhancing visualization, especially when embedding the simulation in different contexts.
And who are credited with creating Simulator?
Fu Qin Wang, Fremont Teng, and Lu Kang Wei.
What about the code for embedding the simulator into other web pages?
That's the iframe code, which allows for seamless integration into other online content.
And finally, what is the licensing agreement for the website's content?
It's the Creative Commons Attribution Share Alike 4.0 Singapore license.
The study guide also includes essay questions. One asks about the pedagogical benefits of using the simulator in a physics classroom.
The interactive nature significantly enhances student understanding. Active participation and visual feedback lead to a deeper grasp of concepts compared to passive learning methods.
Another question explores the potential wave parameters controlled by the sliders.
These could include wave frequency, amplitude, wavelength, and the properties of the reflecting surface. Manipulating these parameters allows students to observe the effects on wave reflection and build a stronger intuitive understanding.
That was a great discussion. Thank you for sharing your expertise on this innovative education resource.